Instead, I'll talk about what I kind of do at Google, but not too much in detail because that's confidential. Hopefully, you might get a flavor of what I do, and hopefully you can also use that. So yeah, hope you guys enjoy. So intro to Kubernetes Operators. So who I am an engineer at Google. I lead a team of about 2 or 3 folks. Currently changing right now with the reorg, and we develop Anthos products, pretty much like Kubernetes for enterprise customers. And so what we do is we take GKE or pretty much Kubernetes and just extend that for enterprise usage. So tailoring to their needs, which is quite different. It took me a while to actually ramp up on to figure out the differences between Kubernetes in the enterprise world versus startup world. Because startup, it's mostly like cloud native. You just, deploy your apps and all of that. But when you're in the enterprise world, you have to figure out, I got to make sure, well, firstly, most of the stuff is all on-prem. So you have to figure out networking and load balancing and all of that within an on-prem cluster, which is very different to cloud. Yeah. So I'm a Golang lover. So this slide, this deck, and the demos are all mostly going to be in Golang. Hopefully that's okay. And I really love Golang. But me being working at Google, just note that every content in this slide is my opinions and that of my own. Nothing here should be linked back to Google at all. Just a disclosure, yeah. All right, cool. So firstly, this is to talk about Kubernetes. We should probably have a cluster, of a Kubernetes cluster. So let's actually deploy one right now. So right here, I've got a Terraform configuration to deploy our cluster. So it's pretty simple. It's saying, let's use DigitalOcean, not using GCP, because I reckon DigitalOcean is better for personal developers like myself. It's cheaper. I can run a Kubernetes cluster for $10 a month. I can't do that with GCP. The minimum is about $72 a month because they charge for the control plane. So yeah, I also do not get sponsored by DigitalOcean, FYI. Great. So it's pretty simple. As I said, you just define that, hey, I want to use DigitalOcean. You provide your token here, which I'll do so in a moment. And you just say what version of Kubernetes you want to use, as well as like the configuration, like how many nodes in your node pool, how many worker nodes, like machines, and the name of the project, for example. So in this case here, that's actually create a token. I will delete this token after this presentation, so don't worry, you can't use this. There we go. Cool. Out of interest, if I run this without adding the token, it should fail. Wrong tab. Yeah, it fails. So let's insert our token here. Right. And it usually takes about 5 minutes to generate this cluster. So let's just move on and let it do it in the background. So I am going to run down quickly what Kubernetes is in a minute or so. That might be a challenge because all videos I see online usually do it within 15 minutes. So let's see how this goes. Before I start, though, is anyone here familiar with Kubernetes or have used it? Raise of hands. Yep. Cool. Great. And how many of you guys have used operators in Kubernetes? Perfect. All right. So just a quick start of Kubernetes. It's pretty much a workload orchestrator. So you create your web apps, simple web servers, web apps, and you put it in a container. So like a virtual machine, essentially. And now you've got one of that, and you put it on a server online somewhere. That's pretty easy. You can do it manually using buttons on like your cloud providers like GCP, AWS, Azure, so forth. But imagine if you have 1,000 of these, because now you're using microservices. You doing it individually for 1,000 of these, ooh, that's maybe possible. You just copy paste, but not ideal. Now imagine if they're constantly changing, values are changing, deployments changing. You kind of want to do that more in an automated, dynamic way. So that's what Kubernetes roughly is. It's a platform, a tool to help you automate a lot of those provisioning. So it's container specific. focus. So you containerize your applications using Docker, for example, and you can scale it across clusters or worker nodes, and it's API-centric. So the key is that behind the Kubernetes, you interact with it through the Kube API server. And there are native stable resources like deployments, pods, services. So deployments is linked to how many pods you want, and pods is like essentially the container or the workload. I know, super confusing, and this is pretty much in a minute roughly. So I reckon the diagram kind of helps more. I'm a visual person. So in this case here, as you can see, the central API server sits here, and we have things called the control plane. So that's where Kubernetes does its magic. It does the scheduling. It tells it, okay, I'm going to put this pod in this cluster, or this workload, this web application in this node. And you can have multiple nodes, and they're just like servers, or roughly, approximately. So you can have 3 different computers, servers, doing your workload, and each of them has the kubelet daemon running that talks back to the central API server that kind of does the scheduling. So when you tell Kubernetes, hey, I want to deploy web app 1, the Kube API will go to the scheduler and says, hey, I've got web app 1 that needs to be deployed. Can you find me a cluster or a node that's free that I can schedule this on and run it? And then the scheduler goes back and says, okay, great, node 1, let's put it on that. All the configurations and things like that are stored within etcd, which is the distributed database. It's a database backing storage, so it's a key value based database. And we have things like controller manager. So what happens if you change the state? You say, okay, now workload 1 should now be pointing to this other app because I've just updated the version. So controller manager is like essentially a infinite for loop that just keeps checking. Okay, has the state changed? Has my workload on the nodes changed? If it hasn't, then update it. And it just keeps checking itself. And you can think of this similarly in terms of robotics, like a air conditioner unit. When you set the temperature as 25 degrees Celsius, maybe someone left the door open and heat comes in, and now the real temperature is 30 degrees. The for loop in the AC unit comes and checks, hey, temperature's now going up because someone opened the door. Well, it doesn't know the door is open, but it knows the temperature's going up. So, all right, let's start the AC unit, bring it back down to 25 degrees. If it's gone below 25 degrees, all right, let's turn it off because it's too cold. So it's like reconcile loop to always correct itself. And that's the idea behind Kubernetes. It's mostly just infinite for loops running to self-correct and always bring it back to the ideal state that you define it. And that state is always stored in the etcd database. Cool. So as I mentioned in controls, what they are is infinite for loops to course correct. They regulate the state of the system, similar to heat pumps. And if you are familiar with Kubernetes, one such example is the replica set. When you say you want to deploy web app 1 to your workload, to your clusters, you can tell it to, say, deploy it 10 times. That's in case one node goes down, you still have 9 others to serve your app. So your customers are always hitting a web app at some stage in time. And then it can also self-heal and bring up a new cluster to bring it back up to 10. So that's what your replica set is doing. It's ensuring that you always have 10 copies of it running. Yeah. And so how do we extend Kubernetes then? Using those concepts, the key concept of a reconcile loop and controllers. Well, firstly, we can create a CRD. So a CRD is essentially just extending the Kubernetes API. So the natural, the default resources we had were deployments, pods, services. We can create more API kinds, for example, to now define new states. And we do that using simple YAML. And why we want to do that is so that we have top-level Kubernetes support, kubectl support, and you can also interact with it directly through the Kube API server. Yeah. And so this comes to operators. What is an operator? Well, the operator is the combination of a custom controller plus a CRD. So it's essentially a Kubernetes native application. So you kind of have it specific to operating an application. So one example might be you want to deploy Postgres, for example, which is a database system. And you do not want to manage the operation of that for day 2 operations. So I don't want to worry about updating it, for example. So you can use the Postgres operator to manage that. You just tell the operator, hey, I want Postgres version 2, and it'll just install that into your cluster for you. At the later stage in time when you want to upgrade, say, hey, let's just upgrade that to version 3. All you have to do is say version 3, and it'll automatically do that for you. How it does that is part of the logic of the operator. So in this case, so when to use it is if it's an application itself and you can control it using a declarative API, and you want to scope it down to like a namespace and cluster level. And it's pretty much just one business logic, really. You don't want it to do too many things, similar to like a microservice. If it's just a simple config file, you can just use just a config map or or Kubernetes secrets instead, where you don't need the infinite for loop. So the key here is operator is if you want that infinite for loop to ensure that the state is always matching the actual representation on your cluster. So without further ado, let's actually just dive into an example. And so what I want to do is to make a serverless platform, functions as a service, as we may call it. Is anyone familiar with what a function as a service is? Cool. So it's basically any developer can just deploy a function to return some sort of response, and they do not have to worry about what the server is, where it is, or how to even deploy that. It's just say, hey, here's my code, do the magic. So this is a simple operator that I've kind of conceived in terms of how I could potentially implement this in Kubernetes. So we start off with the function code, or the function on the left here, and we pretty much just like apply it to the Kubernetes API. We give it to the API, and the API will store it as a CRD. So that's your state file in the etcd storage layer. Then we have our custom operator. So this is the other key part of the operator, or the custom controller. Should I correct this slide actually? That listens and watches that database. When it sees a new function being stored, or if the function's being updated to change the code, it will now create a new config map to store that new code. Then we can mount that code into a pod or a deployment. So injecting that function into like a Python environment or a Golang environment, for example. Then we can run that in the pod and then expose that as a service to expose the ports to the outside world and have it linked to a load balancer on the cloud, just so we can access it as a user. So it's super simple. I'm sure a few of you might notice a few potential downsides with this implementation, but let's start off simple first, and then we can iterate on that in the future. So let's just check out how Kubernetes cluster is doing. All right, it did not go well because I already had one. I forgot to change the name. My bad. Yeah, I just copy pasted an old config file and already had a cluster with that name. But without wasting too much time, I'll just use that cluster again, actually, because you know what? Yeah. So firstly, before we build, there's a few ways you can actually build your operator. As I mentioned, this is an application within the Kubernetes ecosystem. And because it's an application, you should be able to use any language or framework. So here are a few of the popular ones. We have QB Builder, which is a Kubernetes special interest group supported and sponsored project. And it uses Golang and Client Go and a few other packages to build an operator or to scaffold your operator for you. The other popular option would be to go with Operator SDK or the operator framework. And that can actually have you build your operator using Ansible, Helm, or Go. If you prefer Python, you can use KOPF, or you can just roll your own. Use any language, but then you have to do all the manual setup and scaffolding yourself. I know someone's done it in Rust before. Kudos to them. I personally would not. I just like the framework just for ease of development. And at Google, we use KubeBuilder just because it's also mainly the main project for the Kubernetes project as well. So yeah, we use KubeBuilder. As a side note, for the operator SDK, if you're developing using the Go language, it's actually using KubeBuilder under the hood. They kind of merged their projects sometime last year, actually. Yeah. So firstly, we need to get the credentials for the cluster. So let's use my personal cluster, and we can grab the config file here. So this is this allows us to use kubectl to interact with the API server. It's like pretty much like the login details for the cluster, for example. So now with this setup, I should be able to see how many nodes we have in this cluster. So kubectl is how we interact with the kube. Oh, okay, my bad. Yeah, kubectl get nodes. We should have one node. Yep. So we have one worker pool and one node. And so let's create let's start a KubeBuilder project. So right now, let's clear this. So I'm just going to make a folder in my root directory, project, and serverless. And I will initialize a KubeBuilder project using the domain. And this is my GitHub repo. So for Golang projects, it usually uses GitHub repos for the packaging. So it just makes it easier for this, I'll show you in the future, in the next few slides as well. And after we initialize the KubeBuilder project, we need to also create an API. The API in this case is the CRD. So how do I tell the operator what is a function for the user to interact with? I'm using yes here and piping it into KubeBuilder because this is a non-interactive shell. So it's just a little hack. So let's run that. So yep. And it's getting control of runtime and client Go as it's under the hood for KubeBuilder. All right, cool. It's finished. Let's move on. Great. So let's define our CRD. This is how we define our state. So this is the default scaffold that is given to us. And it's in that folder, project serverless. Actually, let's step back. All right, cool. I will show you what the folder looks like firstly. So when we scaffold a project, we get a bunch of files. So you have a Docker file. So essentially your operator is running as a container itself, actually, and that you deploy onto your cluster on the control plane. And there are two folders to note, the API folder and the controls folder. Those are the roughly the two most important folders in this KubeBuilder project. The API is where you define your CRD types. And that's how, like, when you apply your Kubernetes YAML files, for example. And controllers is where you control the logic that happens every time you do that for loop, for example. And main is just the start of your project. So within the API folder, you should see v1 alpha 1, because I started my versioning as v1 alpha 1 when I initialized this project. And within that, typing with one hand is not too easy. we see three files: function types, which defines the CRD type function that I just initialized, group version, and ZZ generated deep copy. So that's just a generated file. But group version here is basically for client Go to be able to inject this into the Kubernetes scheme. So that's how Kubernetes kind of translate your Go files or Go code to the Kubernetes API. That's a really high level explanation of that. You can go deeper, feel free to, but yeah. And within the controllers folder, we should see a couple of files, a test suite for testing your code, and the function controller code. Cool. So let's define our CRD. This is a super basic file that they just gave us. So if you're familiar with Kubernetes, you have the feature spec field. That is kind of where you would normally put your states, or for the user to put the required states. And status is where the operator would put details that you want it to tell back to the users, for example. So in this case, they're both empty, so we can go and fill that out. And you might notice that we have very similar looking stuff to like a Kubernetes YAML here. So you have your metadata field, your object meta field, your spec field, your status field. And this is just a boilerplate for like if you have a list of those, for example. Cool. So when we're building a serverless platform, what kind of input does the user need to give to the platform? Any ideas?
Code and language.
Yeah. All right. So code. So we can do the field as code, and we do not want to have omit empty because we kind of need code for it to run. And the minimum and one way we can annotate this for the open API validation is in the comments here. So for example, QB builder validation min length. So we need it to be, say, I don't know, at least a length of one string or one character. And also language or runtime, for example. Another thing, potentially function name as well, because we want to call a function. Our code doesn't know what function, the name of the function that the user is providing, right? So let's do that. For those of you unfamiliar with Golang, so this is like your struct field, and this is like a annotation when you unmarshal it or marshal it for the JSON name itself. So you can have something else here as well if you want to. And I think that's pretty good for the start. We got the code, the runtime, and the function name. For the status, maybe it might be handy to tell the user when this was last updated so they know what function they're running, for example. So last update time. And I'm going to use the time type. Cool. All right, let's save this. One thing that I want to point out is a lot of the types here are kind of Kubernetes specific. And when I first started this role, previously I was mostly using it as a user, so deploying applications. But now as an application builder within Kubernetes, it was quite difficult to ramp up on, just getting used to all the different APIs and types. But they kind of translate roughly to the YAML files that most developers or SREs would be familiar with. So save. And now let's define the controller logic as well. To save, in the interest of time, I actually already pre-filled this out. I do not want to look like a fool trying to type this out in front of you guys. So basically, you define your reconciler type. This is actually already kind of done for you in the scaffold. So basically, you get this reconcile function, and it's pretty much like a requirement for the interface that the client Go or the QB builder requires. So this is where you put your logic. So you start, I'm pretty much like starting the logger here. And now I'm saying, all right, grab that function struct type that we just created. And now actually get the item that has been placed into the Kubernetes etcd or the API server, for example. So that's what this function is doing. It's pretty much a GET request, HTTP request. As you can see, very API centric. And once we've gotten that, let's now interact with it. So I've gotten it. What I want to do, going back to the architecture, was create that config map, inject that config map into the pod or the runtime, and then deploy it. So in this case, I'm not going to worry too much about the runtime. I'm just going to hard code it as Golang for simplicity's sake. So this is pretty much it. Get the desired config map, deployment, and service and deploy with a load balancer attached to it, so I can access it from the outside world. And feel free to like look through this code. I'm going to have it on my GitHub and as a Docker files, so you can also run this presentation on your own as well. But yeah, that's super high level. But as you can see, once again, very similar to those Kubernetes YAML files that you might be familiar with. And now let's actually just run it. So to show you, on the right-hand side, right now, I'm getting a list of CRDs that are installed within my cluster, and there should be nothing. Oh. Okay. Yeah, not sure why it's not returning anything, but yeah, live demos, right? Yeah. Anyway, we're running the. We're pretty much like installing the CRDs here. Let me go back to one other slide here. Let's change it to shell. Yeah. So right now we just installed the functions CRD, and now let's copy this and paste it. And let's see how many. So right now we have no functions defined in the namespace. Yeah. So let's actually add a function as a developer. So let's deploy a function. So I'm going to do a simple hello world Golang web server that just prints out hello world when we run this web server. So let's call it any function name we want. Hello. And there's an error. Up, yeah. I put the group name. So, yeah. Okay, so control is running. Okay. Not looking well.
Not civilous.
Ah, you know what? You are correct. Thanks. Okay, yep, we've applied this function. Okay, and now shell. We should see, there we go, a hello world now. Now let's see how many pods we have. And we have one pod. Let's see how many services. We should have one as well. And we are generating a load balancer. The external IP is still pending. So once that goes up, I should be able to go into the IP and see hello world. No idea how long this is going to take. Let's go on, move on to the next slide, and then we'll come back to this and hopefully see that it works. Yeah, so one of the problems that I mentioned earlier is that, didn't mention actually, but one of the issues with this is that every function we create, we're creating a new load balancer, a network load balancer. That costs minimum $10 on DigitalOcean. So if you deploy 10 functions, you're deploying 10 load balancers. That's $100 a month. I don't like that. I'm cheap. What we can do instead is actually make a minor modification and have an ingress controller here. So have an internal load balancer in your Kubernetes cluster. So you have a separate load balancer that talks to that internal load balancer that then load balances between your functions. So now you only need $20 roughly a month to run your Kubernetes cluster. And so, yeah, that's one minor fix that you can have. The other one's also changing, so you can have different runtimes like Python and Golang, for example. So should we use this in production? Probably not. There are better options out there. Use a managed service if your output or your throughput is low. So GCP, Cloud Functions, or Cloud Run. They have a really generous free tier. But if you are at the point where you have really high throughput, financially, it might not make sense to use that because it can really burn through your wallets. So then it's definitely better to run your own Kubernetes cluster with your own serverless function platform. So you can use Knative, which is the open source version of GCP Cloud Run. That is pretty chunky as a project because it also uses a service mesh Istio for its backing. If you want something more lightweight, Open Functions as a Service is also another platform. Or if you want something that's actually very similar in implementation to what I just showed you, Kubeless is also another good project. So yeah, let's go back and see if a service is deployed. Great. There we go, and we have a hello world. All right, let's go back. Let's update this. Anything. For example, GDG. All right, let's run it.
You're still in the shell running?
Yes, you are correct. Thank you. Kubectl apply. Let's apply that. And now we should be able to see it doing more reconcile loops. So it's now started a new loop. And let's go back to our slide. I mean, to our reload. And there we go. Cool. Super simple serverless function platform. Thanks.
Awesome. Cheers for that, Ramon. Does anyone have any questions in the audience?
Are there many projects you see using operators? I've seen a few, but is it something that's picking up in like popularity? I mean,
my entire job's operators. So a lot of projects at Google are operator based, definitely. But it's a new philosophy actually. Only came out recently, and CoreOS created the operator ideology pretty much like I think 2018, 2019, and like with CRDs, they only came out recently as well. Like with Terraform, it's only just last week that you can actually use Terraform with CRDs. So it's definitely a new thing, but a lot of applications are definitely coming out with operators. So Postgres, Prometheus, yes, definitely. What's that? Kafka, Confluent, they all have operators now to deploy their applications in a Kubernetes environment. Pretty much a lot of the big names would most likely have an operator. Yeah. So this I just showcased was like, how do I create a platform? But as I just mentioned, a lot of those operators mostly aren't platform based, but rather they handle the day two operations. How do I update my application on the user cluster, for example? Yeah. So it's pretty much like kind of deprecating the job of SRE. Kind of, but not quite. Yeah.
Any more from the audience here? We don't have any other questions online, so what we might do is just call it there. I think we've got some pizza here in person, so some dinner's ready. For those of you online, cheers for tuning in. Sorry, I forgot to unmute my audio to start with, so we missed maybe like a couple of seconds of our intro, but sweet, awesome. Cheers for coming, everyone. Enjoy your pizza, and thanks for tuning in online.